Okay, so now that we know how to find the derivative of the natural log, we can talk about logarithmic differentiation. Now, the question is, when do we want to use logarithmic differentiation? And the answer is, there are two different situations when you want to use logarithmic differentiation. The first one is one that we kind of saw in one of the previous examples, is when you have lots of products and quotients, lots of them. So whenever you're multiplying or dividing a bunch of stuff, lots, it makes sense to use logarithmic differentiation. And I'll show you, of course I'm going to show you how to do it, but that's one of the times when you want to use it. The other case is when you have functions that have function exponents. So you have function raised to another function. Now we don't have any rules for stuff like that. So let me give you an example of each one. So let's say, for example, you have the following function. Let's say you have, let me break these guys up. For example, if you've got the function x to the 5th times x to the 4th minus 3x raised to the 10th times, how about square root of x over 5 raised to the 2x minus 3 times 4x, something like that. I mean, this would be absolutely terrible to do. This is a case where you want to use logarithmic differentiation, and we'll do that in a second. And then an example of functions raised to another function. Let's say, for example, you have, we'll start off with a relatively simple one. How about we just do x raised to the 3x, for example. So this is a function raised to another function, and we don't have a rule to do this kind of a function. We have the power rule. So let me kind of show you. We have a power rule that helps us find derivatives when we have a constant as our exponent, and we have the rule to find derivatives of exponential functions, but that's when the base is constant. In this example, we have both the base and the exponent are both variables. So those are the cases where you want to use it. So now let's actually do one. So let me write down right here. I'm going to write down the steps. Okay. So the first thing you're going to do for logarithmic differentiation, once you identify that it's one of these two cases and you want to use logarithmic differentiation, the first step is to get the natural log of both sides. Okay, so let's start off, let's do this one first. Okay, so I'll get the natural log of the left side and the natural log of the right side. Okay, now step 2 is going to be to break up the right side. So you're going to use the laws of logarithms to break up this guy into sums or differences. So let's do that. So on the left side, I'm going to have still natural log of f of x. And if I use the laws of logarithms to break this guy up, I would get 5 natural log of x plus, bring the 10 down, 10 natural log of x to the 4th minus 3x. And then plus, now remember square root of x, this is the same as x to the 1/2. So this is going to be 1/2 natural log of x. Okay, and then these on the bottom are going to be minus 2x minus 3 natural log of 5. And I'm running out of room a little bit. I'll just go a tiny bit. Then minus natural log of 4x. Okay. Alright, so that's great. So once I've done that, the third step is to get the derivative of both sides. And what I'm going to do is I'm going to use implicit differentiation to get the derivative of both sides. So on the left side I'll get the derivative, and then on the right side I'll get the derivative. Now let's do the right side first, and we'll talk about what happens to the left side after. So here, the derivative of 5 natural log of x, the 5 is the constant, stays the same, times the derivative of natural log of x, which is 1 over x, plus, this is going to be 10 times the derivative of natural log of all this stuff is 1 over the inside, x to the 4th minus 3x, times the derivative of the inside, which is 4x to the 3rd minus 3. So that's by the chain rule. And then plus 1 over the derivative of natural log of x is 1 over x. So this is going to be 1 over 2x. Okay, then minus, remember natural log of 5 is a constant. So this is simply going to be 2 times natural log of 5, because the derivative of 2x is 2. And the derivative of negative 3 is, the constant is just 0. So the derivative of this guy right here is 2, and then natural log of 5. Then minus the derivative of natural log of 4x, which is going to be 1 over 4x, 1 over the inside, times the derivative of the inside, which is simply the number 4. So I'll just put it on top. Okay. So that wasn't too difficult because we've done that before. Now on the left side though, this is gets a little interesting because we have the derivative of the left side, sorry, of the outside, which is the natural log function. The derivative of natural log of f of x is 1 over the inside, which is going to stay the same, so f of x, times the derivative of the inside. Well, okay, the inside, its derivative is going to be symbolized by f prime of x because I don't have the derivative of f of x. So I'm symbolizing it by the derivative of f of x, or in other words, f prime. Well, that's what I was looking for. I was looking for the derivative of the original function, which is this guy. The only thing in the way is this f of x here, but all I need to do is multiply both sides by f of x, and that gets rid of that f of x here. So the derivative of this function is all this stuff that I have inside of here times f of x, which is simply the original function that I had up here. And I'm gonna spare you writing the whole thing down, but this whole thing would go right there. And that's the derivative. So that's the process of logarithmic differentiation. Okay, so let's try this other one. Let's try to do the same steps. Actually, I forgot to write down that last step. Once you get the derivative of both sides, then you're going to multiply both sides by f of x. Both sides by f of x. Okay. All right, so let's try the other one. So let's say we want to get the derivative of x raised to the 3x. So let's go through the steps. Step 1, let me break this up right here. Okay, Step 1, get the natural log of both sides. So natural log of the left side, natural log of the right side. Okay. Now the left side is going to stay the same, so I'm just going to leave that as natural log of g of x. And then this guy right here, I'm going to break it up now using the laws of logarithms. This guy simply comes down in front as 3x times natural log of x. Okay. And then step 3 says get the derivative of both sides, left side and the right side. Okay. Now the derivative of, let's do the right side first. Notice I have to use the product rule. Now here, I'm going to call, so this guy is the first, and this one's going to be the second. So I'm going to have the derivative of the first, which is 3, times the second, which is natural log of x. Okay. And then plus the first, I'm going to leave it alone, times the derivative of the second, which is 1 over x. So notice that these guys are going to eventually cancel. Okay. And then on the left side, I'm going to have 1 over g of x times the derivative of g, or g prime. And then last but not least, multiply, step 4, multiply both sides by g of x. And that's it. That's your derivative. So this guy right here, let me just emphasize, this is the original function x raised to the 3x. But that's it. So that's the process of logarithmic differentiation.